Liferay development pitfalls, how to avoid them, troubleshoot them, and resolve them. This presentation was created basically to talk about issues that developers commonly face when moving to DXP. From the Liferay 6 platform to DXP, OSGI introduces some complexities, but they are easily managed. Unfortunately, at the beginning, the uphill climb to get where you need to be often seems a lot bigger than what it actually is. So I don't know how many of you recognize this, but this is a game from the 1980s, the old Atari platform called Pitfall Harry. And the object in Pitfall Harry was to have him run through the jungle and avoid falling into traps. He was, of course, supposed to save a princess. We're not really going to save a princess here, but we are going to try to avoid the pitfalls. So the first area that we want to talk about is avoiding pitfalls through upgrade choices. When you go through the Liferay developer documentation, there's a major emphasis on the OSGI aspects of Liferay DXP. From an upgrade perspective, I don't think we emphasize enough that migrating to an OSGI modular-based platform is absolutely necessary. Your portlet wars are going to continue to work under Liferay DXP. They require some modification. Leveraging the upgrade assistant in the Liferay IDE will help you address API changes and whatnot, but you can still package those as wars and deploy them. And from an upgrade perspective, taking this path will help you get to DXP faster than if you try to basically refactor everything into OSGI modules. So we always recommend just try to keep your portlet wars as it is, as much as possible. It'll be a smoother upgrade. Look at your new development as OSGI-based development, unless you're forced to stay with portlet wars, as if you're using Spring MVC or JSF, for example. Service Builder is another challenge from Liferay 6 to Liferay DXP, but it is manageable. The challenge is, well, I have my Service Builder in a portlet war. Can I use it in my new OSGI modules? The answer is yes. If I have an OSGI-based Service Builder, can I use that in my portlet wars? Again, the answer is yes. I don't think we make it clear in the documentation that these kind of connections are possible, but I did do a blog post on it that went and implemented each of these scenarios to prove and test out that they were available and could work together. The blog post is available for all of you to go and peruse, ask questions about. I'm more than happy to answer. So the first bullet here really throws people when we say that the portlet wars are deprecated. They are deprecated, but in the same sense, they will have to be supported for who knows how long going forward. Some frameworks, like Spring MVC, are tightly coupled to the servlet container and the servlet context. So from that aspect, it has to be a portlet war to have the kind of context it needs for Spring to work. Until we develop a way to turn that into a pure modular-based system, portlet wars are going to have to exist. JSF is the same way. It's tied to the servlet context. So until that can be refactored to take the servlet context out of the mix, portlet wars are going to be required. If you're not using these frameworks, though, I would recommend doing the OSGI approach. OSGI is definitely the path that Liferay is going to take going forward with DXP and new versions. That's not going to go away. So focusing on an OSGI-based implementation basically sets you up for future compatibility with Liferay. Our next area is avoiding pitfalls through development best practices. This is like my favorite slide. OSGI rewards good design patterns. At the same time, bad design patterns, well, they're not penalized so much, but they can cause you problems. But if you approach it from a clean perspective of, I want to separate my APIs, I want to isolate them into a module where I'm exposing my interfaces, and I have an implementation module where the interface is implemented, but it's not necessarily exported. You start to build a clean system of modules that really promote good reuse patterns in your projects. So one challenge that I often see developers doing in OSGI development is they still want to use the static util classes. And that's because after so many years of Liferay beating into your head, always use the static util classes, it's natural to try to want to do that in your JSPs, in your module implementations. But you really don't want to do that in OSGI. In OSGI, you really want to take advantage of the dependency injection patterns that OSGI supports. The static util classes are there, but they're more for backwards compatibility. And when you look inside, you see that they're actually built using service trackers and OSGI mechanisms to identify the Liferay service, bind it up, and then retain it. It's not really the best practice for OSGI because OSGI's mechanism of doing at-reference injection will not start your module until the service is available. If you're using the static utils, you have no dependency on that. So your module will start up maybe before the Liferay service is ready. And that can run into null pointer errors and other kinds of weird things as your project goes on. So using the OSGI-based dependency injection will ensure that your module starts when it should. Dependency resolution is probably the hardest thing to get right in OSGI development. When you create a module, you're obviously going to have dependencies on other libraries. It's very hard to write a complex module that doesn't depend on something else. But those dependencies are not necessarily going to be satisfied by the OSGI container. For example, I was doing a project where I needed to parse some XML, and I wanted to use Commons Digester because that's a tool that is easy to use and will parse through XML and really make it easy to get into a Java-based model. But that's not provided by the container, so I have to have a dependency on Commons Digester. Well, that in turn has other dependencies on some of the Commons, Apache Commons libraries, and other libraries that also have some dependencies. So you have this transitive dependency tree of things that your module needs in order to run. So managing those dependencies in your module can be difficult because you as the developer have to know not only about the Commons Digester, but all the transitive dependencies. And some of those are required, some of those are not. Only you're going to know that by what you use. Another implementation I did uses Extreme. Extreme has optional dependencies on JOTA time for time conversion from XML. Well, OSGI is not going to know if I need JOTA time. Only I as the developer know, hey, I'm going to be parsing something with dates. I really want JOTA time. Or I'm not going to be doing anything with dates. JOTA time is not necessary. So as the developer, I have to know what I need and I have to include it or exclude it. Liferay dependency versioning. As developers, a common rule is always use the latest version of a library, because that's where you're going to get the most up-to-date version, the one with all the bug fixes, everything else in there. But when you're defining dependencies in OSGI, you really want to go the opposite way. You want the oldest version that you can get away with. Because what you're actually declaring in your module is that you have a dependency on some range of an implementation of a third-party module. So you don't want to be specific about, I need this one particular version, because it might not be available in the Liferay container. Instead, you want to know the range that you can run under, so as Liferay itself changes versions from fixed packs or surface packs or whatever, your code will still run because it still has the necessary libraries to be able to bind to and run. Identifying the pitfalls after you've fallen in. So this is a fun one, the unresolved references. You build your module, you push it out into OSGI, and nothing, it's not there. You drop into GoGo and you see what's going on with your bundle, you try to start it, and it says unresolved reference to XYZ. This is your dependency management issue. You have either a direct or a transitive dependency on something that is not available in the container. So you have to go through and find the dependency, either include it in your module or specifically exclude it. And then you try again, and you're going to wash, rinse, repeat until your module starts. OSGI does not understand the optional declaration for transitive dependencies. So Extreme, for example, has an optional dependency on Joda time, but OSGI doesn't understand that it's really optional. It may be optional at compile time, but it could be a requirement at runtime. OSGI doesn't know that. You as the developer should know it. And you're either going to satisfy the dependency or you're going to be explicit when you say, I don't need it. Sometimes your module will start, but it's not actually working. This can happen because the module and the service starts are connected, but yet they're separate. The module has its own life cycle, but once the module is up, the services then have to start. Services may or may not start if they have references that are either satisfied or not satisfied. You have to drop into GoGo and identify those services that are not started, find out why they're not started, what reference hasn't been satisfied, and make sure that it's available. It could be a reference to a service that isn't available or was stopped or just not deployed yet, but you have to be able to identify those and solve them. Loops can be kind of interesting. If you have two component services that you create yourself, foo and bar. And foo has an @reference dependency on bar, and bar has an @reference dependency on foo. OSGI is not going to be able to start either one of them because the service is not available for it to start. So in order to break the loop, you have to mark one of the dependencies as optional through your @reference annotation. And that way OSGI can start it and later inject the service once it becomes available. So you break the circle, OSGI can start, and it will resolve the references. ClassCastException is confusing. We all know what a ClassCastException is. A cannot be a B. Okay, that's fine. But when you're looking at it from an OSGI perspective, class cast exception does not mean it's really a class cast exception. It actually means that there's some sort of class loader issue going on. So, for example, you cannot cast to an interface. What ends up being is you have a copy of the interface in your own code as well as one in the OSGI container. OSGI tries to apply the one from the container, but there's different versions in the class loader, so it represents itself as a class cast exception, even though it's not. So these become a point of directing you to look at your class loader, see what is in your bundle, what is being used and consumed and exported by your bundle, as well as what's available in the container. Trying to make sure you only have the one version and eliminate the duplicates. Use good bundle names for your modules. This is really kind of important. When you're a developer going into GoGo, you're going to be looking at your beans. And as soon as you list beans, you see that there's like 600 beans that show up in that list. But a lot of those 600 you don't care about. They're all the Liferay services. They're the mechanisms that are just thrown out there. They're going to be started. You don't have to worry about those. You are going to be concerned about your own. Well, you can do LB and pipe and grep on a string. So if you're really good about your symbolic names and bundle names, you can grep on something that makes sense. So if I'm doing something for AT&T, for example, if I use ATT in my names for my bundles, I can do LB and pipe and grep ATT, and that's going to show me only the bundles that I have created. But that means that I have to make sure when I'm doing my bundles, I'm using good names so I can do that kind of piping and grepping on something that's important to me. Avoid spaces and special characters in your symbolic names. Usually the typical sort of package naming rules will apply here. So follow that sort of convention to make sure that your symbolic name is unique and yet meaningful for the organization. For your portlets, do not let Liferay derive the portlet name. This is an optional value that you can specify on the component properties for your portlet. If you don't provide it, Liferay is going to generate one. And we had some problems initially with some of the early releases of Liferay where the name generated had a different format than later versions. So you would have a working portlet one day, you apply a service pack or a fixed pack, and you go in and look again, and now you have the box about the portlet has been undeployed. You didn't undeploy your portlet, it's just that Liferay derived the name, that derivation changed, and so what you placed before is no longer available because it now has a new name. So when you specify your portlet name, Liferay is not deriving it, so you don't have to worry about changes that Liferay might make. Short names are going to be better for you just because of parameter names on the URL, but you still want to make sure that you pick something that is going to be unique. Package exports. Only export packages that other modules will use. You don't want to export a package for something that nobody else is going to extend or invoke or override or whatever. Follow the basic kind of pattern you're going to choose for public versus protected versus private. So the same sort of access rules you want to apply to your module, you're going to apply to your package exports. Do not try exporting the same package from multiple bundles. This is not going to work. This is going to cause you problems. Always make sure that your package exports are unique to a specific bundle. OSGI is not necessarily fully cluster aware. So when you do things in the cluster, sometimes it's going to make it to the other cluster nodes, other times not so much. Just like when you do a deployment, if you deploy a module to one OSGI container, it doesn't propagate to your other nodes in the cluster. You have to manually deploy to each one of those clusters. The challenge here is going to be that if you're doing an update, if you only do one node, the other nodes may have an older version, things may look like they're okay, but you might have issues because you have different versions now across your cluster. So you want to take care to make sure that you do everything up on each one of the nodes in your cluster to make sure that the changes propagate. And, you know, when you run into problems, the forum's a great place to find me, as well as other talented and experienced people. The forum can really help you get out of a jam if you find yourself in one. That's really all I have. Do you have questions? Woohoo! Great. Well, I will be here today and tomorrow. I'll be milling around with everyone. Please feel free to stop and talk to me, ask questions. Tell me your stories. I'd love to hear challenges that you guys are facing as developers. I'd love to try to turn that into a blog so that I can help you and others be successful in your Liferay development journey. And most importantly, don't get discouraged by the complexity that it may look like with Liferay OSGI development. Having done so much, I look back now at my Liferay 6 development and Liferay DXP development, and I realize things are much easier for me now. It takes you a while to get there, but you can get there. Oftentimes I think that someone new to DXP development has an easier path than those of us who might have been developing for Liferay 6, because there are pieces that we have to unlearn in order to be successful with OSGI that new folks don't have to worry about. They don't carry that baggage. But you can be successful with DXP development, and it just takes a little time to master the different techniques in order to get there. But you can do it. All right, thanks.